Billions of dollars are on the line in the promise of hydrogen-powered flight. But before the first passenger flies emission-free, we must solve how to store a super-cold, bulky fuel and how to get it from the factory to the aircraft wing on a scale never before seen. Is the industry ready for its greatest challenge? Because aviation, as we know it, relies almost entirely on jet fuel. And burning jet fuel releases millions of tons of carbon dioxide into the atmosphere every year, contributing significantly to climate change. Global pressure to reduce emissions is driving the air sector to seek radical alternatives, and that's where hydrogen comes in. Imagine an aircraft that, instead of carbon dioxide, primarily emits water. That's the promise of hydrogen. A fuel that, if produced sustainably, could offer commercial flights with virtually zero carbon emissions. It's a bold vision, and that's why industry giants are in a race against time to make it a reality. In this race for clean air, two titans clash with distinct philosophies, Airbus and Boeing. On one side, Airbus has taken the lead with a bold and public strategy. They've unveiled their ambitious zero concepts, showcasing revolutionary hydrogen-powered aircraft designs, and have set a clear goal to have a zero-emission commercial aircraft ready by 2035. It's a strong bet, a clear vision of the future they aim to lead. But on the other side, Boeing maintains a more cautious, perhaps more pragmatic stance. While they research hydrogen and acknowledge its long-term potential, their message emphasizes the gigantic challenges of the necessary global infrastructure, from production to refueling at every airport in the world. Their approach seems more diversified, also betting on sustainable aviation fuels and efficiency improvements as crucial and more immediate steps. You won't see a timeline as firm as 2035 from Boeing for a new exclusively hydrogen aircraft. It's Airbus's bold vision versus Boeing's caution based on ecosystem complexity. Two different paths towards the same goal of reducing emissions. But how do these giants and their partners plan to move those aircraft with hydrogen? That's where the true wizards of technology come in, the engine manufacturers. Because the visions of both Airbus and Boeing depend on future engines being able to burn or convert hydrogen efficiently and safely. This is where propulsion titans like Pratt Whitney, Rolls-Royce and GE Aerospace are innovating relentlessly, exploring mainly two paths: adapting jet engines for direct hydrogen combustion or using fuel cells to generate electricity. Take Pratt Whitney, for example. Their HySIITE concept is a display of sheer ingenuity. They've redesigned a GTF engine to burn hydrogen, yes, but the brilliant part is how they manage the resulting water vapor. They collect and re-inject steam into the combustor. The result? An incredibly effective way to nearly eliminate nitrogen oxides, a problematic byproduct of burning hydrogen at high temperatures. It's an elegant and efficient adaptation of the traditional engine cycle. For its part, Rolls-Royce is attacking the challenge from multiple fronts. They're not only adapting their powerful jet engines, like the Pearl family, for ground testing with hydrogen combustion, but they are also pioneering the development of megawatt-scale hydrogen fuel cell systems designed specifically for aviation. The genius here lies in making these fuel cells and electric motors light and powerful enough to move medium to large aircraft, opening the door to hydrogen hybrid electric or pure electric designs. And let's not forget GE Aerospace, often working through their CFM international collaboration. They are exploring hydrogen combustion integrated into advanced engine architectures like the open fan concept from the RISE program, which seeks unprecedented efficiency. Their ingenuity lies in combining hydrogen's high energy density with radically more efficient engine designs and developing high-power electrical systems for potential hybrid configurations. These manufacturers aren't just designing engines. They are reimagining how an aircraft gets its power, developing the fundamental technology that will allow zero-emission aviation to take off. But no matter how innovative these engines are, they cannot operate in a vacuum. The truth is, flying aircraft with hydrogen requires a complete revolution that goes far beyond the engine itself. The real giant challenges lie in how to handle this unique fuel. Think about onboard storage. Liquid hydrogen needs to be kept at extreme sub-zero temperatures, minus 253 degrees Celsius. This means special tanks, very large, heavy and bulky compared to kerosene tanks. They don't fit easily in the wings, forcing radical aircraft redesigns. And you have to prevent it from evaporating in flight or on the ground, a constant logistical headache. And then the ground infrastructure. How do we get green hydrogen to every airport in the world at the necessary scale? This requires new hydrogen factories, perhaps thousands of miles of pipelines, or a massive fleet of cryogenic truck tankers. At airports, entirely new, large-scale storage facilities and refueling systems are needed as fast and safe as current jet fuel systems. We're talking about massive global investment and unprecedented logistical coordination. And this is precisely where the advancements and performance promises from engine manufacturers become the master key. It's the prospect of achieving 35% greater efficiency with concepts like HySIITE, or virtually eliminating NOx, that begins to chart the course. It's these tangible improvements and the value they provide that justify governments, energy companies and investors mobilizing those billions of dollars needed to build all that infrastructure to support the aircraft. So, where does this exciting hydrogen race leave us? We've seen that giants like Airbus and Boeing are approaching it with distinct visions, relying on the incredible engineering of engine manufacturers like Pratt and Whitney, Rolls-Royce and GE. We've explored ingenious technologies designed to burn hydrogen or convert it into electricity for flight. And we've put on the table the colossal challenge of creating entirely new global infrastructure and onboard storage systems that are safe and efficient. The transition to hydrogen aviation won't be easy or cheap. It will require massive investment, continuous innovation, and unprecedented collaboration across the entire industry. But if we succeed, the promise of a future with zero-emission commercial flights is a goal well worth pursuing. It's the next frontier of aviation, and the race to conquer it is more alive than ever. Now we want to hear from you. Do you think hydrogen is the future of aviation? Which of these technologies do you find most promising? Let us know your thoughts in the comments below. If you found this analysis interesting, please give the video a like. And to not miss future videos on the innovations reshaping flight, make sure to subscribe to the channel.